Boundary value analysis. Now when you are traveling, you don't have map. Assume you don't have map. So if you're going straight, you don't have to ask anyone. But whenever you have multiple turns or a cross intersection, then you have to read the board. Here you have the problem. Similarly, most of the time, in the coding, the boundary values create problem. So boundary value analysis is one of the widely used test case design technique for black box testing. This is used to test boundary values because the input values near the boundary, they have higher chances, higher probability of error. So we'll make the partition, valid partition, etc. But error occurs more at the boundaries of the input domain rather than the center. So boundary value analysis leads to a selection of test cases that will exercise the bounding values or boundary values. So this boundary value analysis, it is complementing the equivalence partitioning. Once you have made the equivalence partition, say for example 2 invalid class and 1 valid class you have made, you see the examples also is given. And how do we do the boundary value analysis? In these 3 equivalence classes, we will take these boundary values and then apply the test cases. So boundary value analysis leads to selection of test cases at the edges of this class, equivalence class, if you apply equivalence class partitioning. So boundary value analysis, not only for the input domain, you can derive test cases for the output domain also. This is very important. For example, if you have divided this whole range into valid and invalid classes, for example, equivalence partitioning you have done, then the actual boundary value analysis will be done at 18 and 30. That is a value which is near 18 and near 30. So 28, 30, 31 and 17, 18, 20. These are the values which are of your concern while applying the boundary value analysis. These are the value I am making circle. Sometimes people say that the boundary value analysis, if we compare with the equivalence partitioning, though they are complementing each other, but BVA is considered more better because it may take the positive and negative values both, along with the minimum and maximum value. So what are the guidelines for BVA? How do you actually do it? So the guidelines or the way you are going to do it is, if an input condition specifies a range bounded by say values A and B, say A is 10, B is 100. So test cases should be designed with values A and B which are just above and below both A and B. For example, 10 you will take 9 and 11 also, 100 you will take 99 and 101 also. If an input condition specifies a number of values, if you have number of values, then what you will do? You will take the minimum and maximum numbers and then you will use the test case for minimum and maximum. And then the minimum, which is the value which is just above and below minimum and above and below the maximum. And this too also can be done to the output condition. For example, if you have a temperature versus pressure table, this is required as output for say certain engineering analysis program. Then how do we apply boundary value analysis to this output condition? The test cases should be designed to create an output report that produces the maximum and minimum allowable number of table entries. If you want a table, what will be the maximum allowable values? What are the minimum allowable values? This has to be done. This has to be your test cases. This is for the output condition. If the internal program data structure, they have prescribed boundaries. For example, we are taking array, defining an array. Now if this array is 100 you have defined, so you know array starts with 0 and with 99. Most of the time the error comes at 100. If you want to access any number which is higher than the array being defined, there will be an error. So you have to check it at 98, 99, 100 and in between also some value. So a table has a defined limit of 100 entries, right? So be certain to design a test case to exercise the data boundary at the boundary. Now these are the valid and input, say classification we have done, equivalence classes we have made. And then what you have to do is you have to take the values which are at the boundary of these classes. Negative, positive. That is how boundary value analysis works.